This is an update really of a webinar I did last year on whole life carbon, mainly because there's been some changes in the last quarter of 2023. And actually, as late as yesterday, there was a ministerial statement um, that adds to the complexity of what we do. So without further ado, let me just, so what I'm going to do is talk about what is whole life carbon, the updated RICS structure, how we go about calculating whole life carbon. Um, if you haven't heard about it, what was the London Energy Transformation Initiative is now the Low Energy Transformation Initiative, so it's going nationwide. We'll touch on building circularity, some design tips for reducing whole life carbon. The things you have to have in the back of your mind when you're sort of entering into stage two. And then we'll touch on changing and emerging policy. I'll run through a case study, which is actually a mix of it was originally we look at that from a retrofit point of view, and then we've got a comparison new build for that same site. And then we just wrap it up with some takeaways at the end. So the reason whole life carbon is important is that it encompasses the complete life cycle of a building. And when I say that, I mean everything from taking the raw materials, whether they're harvested or extracted, turning them into products that we assemble and then use and then disassemble, recycle, upcycle, so on and so forth. And so it includes everything, including transportation, water usage, energy consumption and generation. So it's much more encompassing than just the building regs alone. So the whole life carbon is calculations based on the RICS guidance, first published in 2017. And what it seeks to do, we're concerned with more than just the regulated energy that we see in the back end of a SAP or an SBEM calculation. We're concerned with the materials, the operative energy, and so on and so forth. And it's consistent and it's comprehensive. It's now becoming widely adopted, sort of outside the UK as well, in principle. And of course, it appears in BREEAM under the management and materials section for issues and credits there. What it covers is everything from, so if we're talking about a retrofit, everything from demolition, and what we do with the carbon at the end of the life of a building. So, have the REBA digital planner works in the back of mind, the back of your mind, that circle of the stages. And it also includes facilitating work, the foundations, superstructure, whether it's timber, steel, concrete, etc. The finishes, if you've got details on FF&E, that goes in. Certainly from a mesh perspective, we spend a bit of time quantifying the building services and including that in our calculations. And it includes prefab, works to existing buildings, and it can include external work. So we can, you can include landscaping design in that as well. So September last year, RICS released the second edition. So I don't know how many of you are familiar with this structure already, but it's broken down into fundamentally 4 modules in terms of life. So the first sort of 10 or 15% is module A, which is everything to do with the construction through to practical completion. Then we have module B, which is the life cycle, the sort of the occupied in-use life of the building, and it includes everything, all the operational side of that. Then we have the end of life, which is very short, and that's to do with demolition, processing the waste. And if you've designed for adaptability and deconstruction in module A, then there are benefits to be had in module C and also into module D. So module D is um, the carbon associated with the project after the afterlife. So it's where you take materials that have been used, what you do with them, how you treat them. Do you reuse them as they are? Do you reprocess them into something else? And that contributes to the whole life cycle. And underneath all of this, we've got the operational energy and operational water. That was all that was existing. So operational energy includes regulated and unregulated energy. So when we talk about regulated energy, I'm sure you're aware that'll be the heating, hot water, and lighting. Operational energy starts to include small power loads, um, and all the operational emissions that come from that as well. So it's all the unregulated energy as well. So the process that backs that up is a method called CBC TM22. And that can either be done as sort of a desktop study to understand operational energy, or if you're working with us, then we do a lot of dynamic thermal modeling, where that becomes a lot more involved in terms of occupancy profiling, time of use, and so on and so forth. The addition is user activities that don't come under B6 and B7. So this is going to be carbon emissions associated with the running of the building that were previously excluded. So it can be, for example, um, if you've got commercial office, then it can be business travel associated with um, the running of the business and the occupancy of that building. So the scope is starting to expand, and so we're and all these figures are basically normalized. I mean, they can be turned into different rates, but typically in the construction industry, we work in kilos or tons of CO2 equivalent per square meter. And you'll see that in the LETI and the REBA guidance. RICS, Institute of Structural Engineers, are put all on board with this. So everybody from different aspects of the industry are now involved in this life cycle and understanding it, and also marrying that up with the digital plan of work. So we're all really starting to sing from the same hymn sheet in a significant manner. And this diagram is now in the second edition. It starts to show the flow of materials and recycled materials, and how the calculations are changing. The software is not yet updated. It will come out probably in the next, I think it's next month. We're expecting updates to the platforms that we use in order to calculate whole life carbon, and it will take into account all these processing flows of materials and how we count the carbon. So it's going to get a whole lot more complicated. So over the course of last year, for example, began to find that the amount of effort that was taken for say energy modeling, sustainability statements, that sort of thing, um, whole life carbon is now starting to almost take the same amount of effort in understanding the whole life of the building, mainly because it's all about those upfront stage 2 design considerations as to not just selecting the materials, but thinking about energy strategies and materials and use, sort of durability, end of life, adaptability, and so on and so forth. So what we're going to see is at stage 2 a lot more holistic whole life thinking about the design of buildings. So let's go into a little bit more detail of each module. So module A is what we call the cradle to gate stage. And this is everything to do with processing of raw materials, extracting them, taking the timber, the minerals, turning them into other materials that are then assembled into products, whether it be MVHR, duct, or heat pumps, boilers, radiators and so on and so forth, paint, every aspect of the design of materials of the building can be captured at this stage. And it includes things like transport. Transport is particularly interesting because often we'll have conversations about cross-laminated timber, for example. It's a wonderful material, it's robust, it becomes part of the structure of a building. It can be aesthetically pleasing depending on how you use it. And it promotes a far more accurate method of design and construction. So it's more, so it reduces waste. Now, the reason the transport is important is not, more often than not, is that at the moment CLT comes from the Alps or Scandinavia. So there are higher carbon emissions associated with sea transport, for example, and then road transport. And then we get into the construction phase. And the thing to think about at this stage is, do the products you're using have environmental product declarations? And these are becoming more commonplace. This is really an evolution out of, say, the Green Guide for Specification, for example, where for a particular form of construction, you might have a sort of what is now a very rough and ready rating as to how green or sustainable a design approach might be. But now, we're starting to, if you're working with BREEAM, for example, then you can improve your credit score by doing a lot more work in sort of assembling environmental product declarations. So this is kind of the next step on from FSC for timber, for example. So we can really understand what the global warming potential of the material is, and it starts to influence, for example, the choice and placement of insulation, which has got a high GWP, and there are often opportunities to manipulate that so you still get the same thermal performance, but you can bring down the carbon footprint of the building. Now, RICS have some default specifications in there. So, there's a degree of recycled content in each of the sort of key materials. But of course, these can now be, there's wider forms of or types of materials becoming available. So if anyone's aware of the London sewer project that's going on under the River Thames at the moment, that actually uses cement-free concrete. That is a significantly large project with a lot of structural challenges to it. So the level of confidence for them to make that material choice, I think, really tells us a lot. But it is worth bearing in mind that as we start to use more recycled content in concrete, for example, then it will start to extend the curing time. So, on the one hand, you can use recycled aggregate, but on the other hand, when you get to your stage 5, then your construction program might extend slightly. But of course, all these materials, like I said, have got more and more recycled content available now. So, there's plenty of alternatives. For example, plasterboard. You can use clayboard, for example, as an alternative. The standard insulation is PIR, which has great thermal performance, but is terrible for the environment. So you have to start considering things like wood fiber or more organic insulation, which they all have a similar thermal performance to, say, rock wool, but you end up with, say, thicker walls, roofs, and floors. So you have to bear that in mind when the space planning, for example. And then, as I said before, we include transport for all journey stages. So the further away your materials are made, then the greater the impact. So, for example, solar panels are often, they're made, or more often than not, are manufactured in Asia. So they have extremely long transport times. But when you look at energy generation, depending on the scale, really, you can offset the carbon cost of that transportation, or that upfront carbon cost, usually over about a 16-year period. So you get about 9 or 10 years where you're getting a carbon benefit from things like solar panels. But what it does mean, it's all about trying to source more sustainable materials in a within a smaller radius. So, I mean, in the UK, because we're an island, we're kind of fortunate that most materials can be sourced within about 70, 80 miles. So it's not a great distance. But like I said, CLT is one of the more problematic forms of construction. And then we allow for construction and installation of the building and the carbon emissions associated with that. And something you can do at stage 5 is actually, certainly the part of BREEAM is the principal contractor could record their in construction carbon emissions, and that can be reported back as part of the end of module A. So everything's up for grabs, really. Module B is the in use. So this is everything to do with the operation and maintenance of the building. It can be, say, replacement of building services plant every 15 to 25 years, for example. It can be repair, painting, maintenance, and so on and so forth. And by using EPDs and materials that have been assessed, those EPDs, when they enter into these carbon calculating databases, include all those factors in the background. So when we start to run these calculations and we get the results for module B, the maintenance, say for redecoration of the paint, has been taken in, is factored in, and it starts to form the carbon footprint of the building in use. And as I said at the beginning, it also includes the regulated and unregulated energy use and the on-site energy generation. And this, of course, this relates back to the the LETI energy use intensity metric, which is kilowatt hours per meter squared per year. And of course, it includes operational water. So this is potable water use. Energy is required to supply or process and supply potable water to buildings. And so off the back of a approved document part G calculation, then that can be factored in. There is replacement life cycles as part of the RICS structure. These are all fairly standard, really. It's sort of 30 years for the fabric of the building, anywhere between 15 and 25 years for building services. And of course, the facade is 30 to 35 years for replacement and sort of repair activities, really. And then we get the end of life. And this includes the deconstruction and demolition activity. There's a site activity, so there's a carbon footprint associated with that. There's a transport to the disposal facility allowance that can then be calculated. So the more local the waste processing, the better. And actually, when we're doing calculations, one of the conversations we do have with architects is for each individual material that is included in the design of the building, we can actually specify the treatment of that particular material at the end of its life. So, for example, concrete, brick, and block can be crushed down for the use of aggregate afterlife of the building. Ideally, and we've worked on projects like this, then they would use recycled brick, so you can classify the brick being reused as a material. And similarly for timber as well. So the default position for timber, for example, is incineration. Now, if you can design a building where the timber is designed for disassembly, and most of the timber can be actually reused as timber, then of course it reduces the carbon impact at the end of life of the building, and then of course there's the disposal. So the more design for adaptability and deconstruction there is, then the more benefit there is at stage D. And this is all about the potential for reuse, recovery, and recycling of materials, or downcycling of materials. And it's communicated separately from module A and C because it's outside the life cycle of the building. But say those materials were to be used in another building, following on from the deconstruction of this one, then when you're looking at carbon sequestration in module A, then the module D contributes to that new module A. So it's starting to, this way of thinking supports building circularity as well. And I'll touch on that a little bit later. So carbon sequestration is included only, the benefits of module C end of life, or the FFC or PEFC of timber after the life of the existing building and use in the new building or new project. It doesn't have to be a building. There's plenty of other uses. So there's a lot of calculating that goes on. Now, we use impact compliance software, and impact was developed back at the beginning. Well, I first started using it around 2013. It was developed by BRE and a number of industry stakeholders, and it was the early days of in the UK of doing life cycle assessments, life cycle costing. It has CAD BIM interaction, for example, and it's BRE compliant. So when I say it's the BIM interaction is there, for example, if we're working with dynamic thermal models with fully made up constructions and so on and so forth, we can export all that data into what we use as one-click LCA, which is an impact compliant tool. We can export everything into that, and then we can start to fine-tune and include materials and products that are not necessarily included in a dynamic thermal model, but have a part to play in the whole life carbon of the building. So it gets used in BREEAM, CSR, cost benefit analysis of design options, and so on and so forth. And it has sustainability kudos credentials as well. So, for example, like I said, we use IESVE with one click, and it contributes to 77% of the excellent credits, and it falls within 7 of the issue areas relating to project management, health and well-being, the energy and water strategy, and so on, right through to minimizing pollution. And we apply this to all our projects, regardless of type, scale, or BREEAM scheme. So we've used this on hotel and leisure, civic offices, right down to sort of paragraph 79 and domestic schemes as well. So it's perfectly scalable and consistent. So in terms of presenting whole life carbon, I think the low energy transformation initiative is probably the most robust, consistent means of presenting the data now. And the nice thing about it is that LETI is a pan-industry body, so it includes civils and structures, architects, building services, QSs. There's all manner of people involved in establishing the LETI design guides and metrics. And because of that, it's grown out of the REBA sustainable outcomes, which originally were intended to support the UN sustainability goals. So this evolution of whole life carbon over the last 3 years has actually been quite intense, and it's become quite involved. So it's a very it's become a very useful mechanism in sort of de-siloing thinking about how we construct buildings as well. LETI is a little bit complicated. run the calculations for module A to C, so the whole life of the building, but it does exclude the operational energy and water use because it's all about just assessing the building as an object and its use and its sort of materiality, building services, and so on. And it's looking for at least a 60% reduction in embodied carbon compared with the baseline today. I mean, I think the business as usual embodied carbon figure is somewhere around 1,200 kilograms of CO2 equivalent per square meter. So it's quite a significant change. And it also ties in with reducing the energy use intensity as well. What's interesting as well is that I've been talking about deconstruction and adaptability, but it's also asking that designers look at building circularity. So, 50% of the material is reused in the design. So, start thinking about what percentage of previously used material you can use in your scheme, and how much of that material will be then reusable at the end of life of your scheme. And it's demanding. I won't try and fool you with that. It takes an awful lot of effort and fine tuning to and discussions about particular you know, particular material within the design of a fabric of a building and how we actually look for suitable alternatives and bring down the carbon footprint. So lowering whole life carbon is a bit of a cat's cradle. Imagine each finger is a variable in the design of the building, and as soon as we move one of them, it pulls on the others. And so we're constantly trying to reconcile all these different factors for the best possible outcome, really. Um, so think about form factor um, in terms of managing passive solar thermal gain for overheating analysis, and also a for example, domestically a mid terrace is twice as efficient as a bungalow. The same actually applies with a commercial scheme I'm working on at the moment. And ask yourself, with Fabric First and the AJ sort of initiatives over the last year or so, is refurbishment better? And that becomes when I'll introduce you to some emerging policy and why that question is particularly important. Um, are there historical or aesthetic factors of concern? Can you change the superstructure? Can the amount of superstructure be reduced? Is it possible to, design it for deconstruction? Can we be more choosy about the position of particular materials within the fabric of a building so you get that durability and longevity as well as really good thermal performance? I mean, can you build more organically in terms of selection of material? So more organic insulation structure while reconciling that with resilience and designing for end of life. So designing for whole life carbon, you're thinking about all aspects of the building. There is changing policy. The last couple of years, we've seen plenty of climate emergency declarations for retrofit, and that is now entering into um, planning discourse as well. And we've started to see that gain traction over the last 6 to 8 months. It started in one part of the country. We're starting to see it in other areas of the country. And these declarations support sustainable new build. It's all about getting away from business as usual. It's becoming widely recognised that business as usual approaches to construction are not going to get us to where we need to be in terms of a more sustainable built environment. It's also recognised that SAP is not a realistic way of understanding the energy gap, and dynamic modelling of energy use intensity is becoming more commonplace. The Future Homes Hub have just put out a consultation for feedback on how to replace SAP. So it's going to be interesting to see how that develops. And of course, we get lots of there's the lobbying. We've got the AJ Retro First campaign, and there's a pan-industry sort of move to, we're pushing for building reg part Z, which is about looking at the whole life carbon for the built environment and actually making this a legal requirement. So this is a example of an emerging policy. It originated down in the West Country. It's now gaining traction along southern counties, down in the southeast, up into East Anglia and across into the Midlands. And we've done work on projects where this is not yet part of local planning policy, but the planning officers would like to understand it in more detail. And so we increasingly get asked for this form of calculation. And it's one that's to be treated very carefully. So on the screen at the moment is a calculation for the same property with two very slightly different approaches. And what the policy actually asks for is that if you're going to demolish a building and build a new building, then the payback period of the carbon cost should be under 25 years. Now, when you look at the RICS structure, the way that suggests or guides that it should be calculated is that you take the end of life carbon footprint. So how much carbon is at the end of life of the building through deconstruction and reprocessing. It then asks what the upfront, the module A carbon footprint is of the replacement dwelling, and the amount of carbon that could be recovered through module D of the existing dwelling. And what that does is give you a net carbon cost of the project. And it then looks at the SAP calculations for the new build, so the TER and the DER, and it provides the annual saving. And the combination of those figures basically determine the payback period and whether it's compatible with local policy. Now, one of the policies we're quite commonly working with at the moment skews this. So the previous administration sort of got behind the AJ retrofit campaign, but in order to narrow the design constraints, they require that the upfront carbon of the existing structure is calculated, not the end of life. And as you can see, it's 5 times higher. It doubles the carbon cost of the project, and it increases the payback period hugely. So we have to start looking a little bit more closely at how we can improve the fabric or the material performance or the carbon performance of the fabric of the building, as well as the TER and the DER. So we're looking at fabric first. We're also looking at the materials. The architect is also having to look at the gross internal floor area and make sure, along with the clients, that everybody is happy that the project is going to deliver what they would like. But at the same time, this carbon calculation is just one aspect of the project. So if, say, for example, there are structural challenges or material challenges with the existing building, and it's been built in such a way that it's impossible to retrofit. I mean, there are some materials out there that literally it's like working with sandcastles. And so it becomes part of the consideration. So we've got another project which is on the side of a hill. It's causing all sorts of structural issues in terms of subsidence, and that is now, we've been having that discussion over the last couple of weeks with the client and the architect to understand how we can change or what we do with the narrative in design and access statement and get the structural engineer more involved at stage 2 to give professional statements about what would be required to retrofit the building, and also understand the carbon impact of that. But to give you an idea, I mean, if we can, through collaborating, I mean, if we can start to make some very subtle changes, so if we can get the upfront carbon of the existing building down from, say, 35 to 30 kilos per square meter, if we can improve the U values and the air tightness and reduce the DER by 1.5, then we've also immediately moved through some quite minor changes, really, from 50 years to a 35-year payback. Now, with the context of this project, the planners have suggested that that would be a reasonable figure, given the narrative surrounding the structural integrity of the building. However, there's been a ministerial statement in the last 24 hours about the challenges of getting planning approvals, and some of the planning consultants that we work with have picked up on this because it includes what they've noted the assessment of embodied carbon as a potential barrier to new projects. So this has kind of put a spanner in the works a little bit. Just when we thought we knew where we were going, that we've got a slightly different policy, because they're saying that these additional requirements should not impact the viability of a scheme. So it's it's a changing landscape, and where new planning applications, which are like these sort of policies surrounding whole life carbon, are might be seen as additional performance standards, then they should be challenged, and they shouldn't be seen as a barrier. So there's quite an interesting discourse going on at the moment, and we're just trying to have as many conversations as possible to see how this is going to pan out. So let me just go. How are we doing for time? Right, let's just go through a case study. And this was on the south coast. It's an existing property that's favoured by the Victorian Society, and the client would like a larger home, but we need to bring down the whole life carbon. The architect is preempting the question surrounding whole life carbon from the planning officers of this project. So what we did was have a look at the existing house, what we could do to improve it, and how that compared to the proposed design. So it's an existing Victorian building, it's on oil. We looked at improving the glazing, doing some sort of AECB aligned retrofit work on the fabric of the building, and moving over to a ground source heat pump. And actually, we knew that we can reduce, the the carbon footprint of the building by improving the existing house. But the argument from the client was that it wouldn't meet their needs, and therefore they would have to extend it. And so we had to expand the level of analysis that we were doing and asking questions about, how much embodied carbon is in the existing building, for example. If you improve the existing house, how much module A embodied carbon are you adding to that building? And are we improving the fabric enough to make a significant difference? And is the argument for demolition or new build too weak? So especially if the cost of module A, like that previous spreadsheet I was showing you, is embedded in the carbon of the existing property, is added to the proposed property. So suddenly, the improved fabric and energy strategy, we get a much better, slightly better performing building, And if we were to demolish and rebuild and put in, you know, state of the art renewable technologies and go for, really go for the fabric first and so on and so forth. But at the same time, the gross internal floor area of the existing property would need to match the proposed dwelling to be a fit for purpose property, and we'd need to do a like for like comparison with that. So what we did was have a look at taking the existing house, improving it, and then adding an extension that would give the gross internal floor area that was required with the new, the additional new forms of construction, moving over to a new energy strategy and so on and so forth. And we could make a significant reduction, but what we then did was do the analysis of the proposed design. And this is a very organic building. It's on, organic material building. It's on the coast, so it's got a very durable outer skin on it. But even so, because of the improved U values and that organic material, we could bring down the carbon footprint even further. So we can make huge improvements. It's just a case of building, the right case. And of course, there were some external benefits on that as well, very very minor because of the state of the existing building, but it is there and it can be calculated. And then we took all this information and then started to put it into the context of the Letty scale, to understand what the upfront embodied carbon is and what the life cycle embodied carbon is of the existing property, and then what would happen by adding this extension and doing this retrofit. Now, the problem with the retrofit is that because we wanted to reduce the impact on the existing gross internal floor area, we had to use high GWP insulation. So the embodied carbon rating of the overall design started to get worse. But then when we looked at doing a complete new build, then of course with the more organic insulation, we've got really low upfront embodied carbon. I mean, this is fantastic in terms really, and also low life cycle embodied carbon because of the choice of materials and finishes and so on. So time 10 minutes. So circularity. Briefly, building circularity is all about getting away from the use of virgin material. So it's all about reducing module A upfront embodied carbon and starting to pull in materials from module C and getting that reduction through the module D afterlife in the building and bring across that sequestration in timber, the carbon saved by reusing, brick, for example, and so on and so forth. But there are some couple of really good guys. I mean, Ellen MacArthur Foundation's got a really good thing about building circular economies, and also it's embedded in London Plan as well. So there's plenty of background reading to do in understanding this in more detail. Can't really go into it today. So it's sort of in terms of design, I mean, what the questions you have to ask yourself, and we're doing this with the moment, is really understanding, realistically, what percentage of material do you think you can recover from an existing building and reuse an existing in a new build? We've got a project on the go at the moment, which has got a slate roof. It's crikey, how old's the building? 80 years old. So the architect is a little bit wary about the integrity of the slate and how much could actually be recovered. So we're having to make a judgment call on how much of the slate tiles could be successfully removed from the roof and actually reused in the rebuild of that project. And then go, back to module circularity briefly. Can we reduce module C and increase module D? Can we, the amount of virgin material to 85%, and only, sort of 6% that could be recycled. How can we change this circle? And it is all about, as I was saying right at the beginning, is looking at the choice of material, how we propose treating it at the end of its life, designing for durability, but also deconstruction. And then we can start making changes. So depending on the type of material and its treatment at the end of life, we've shifted the recycling tenfold. So we start to get that module D benefit out of a project, and we can pass it on um, into um, the sort of the overall design narrative. So this particular house, these were the upfront and life cycle embodied carbon for the average design and what REBA 2030 sustainable outcomes require. Um, and then how the existing house stood in terms of its use of materials. Um, what would happen if we improved it? So again, you can see on a very simple level, the improved existing house to get the thermal performance would actually have um, a worse whole life carbon outcome. And then by demolishing that building, treating the materials for the existing house, then we could really get the proposed design up front, whole life carbon down, and we start to get into A-rated whole life carbon design. So takeaways. It's no longer just about Part L. It's about the whole life of the building, how it's used, what it consumes. Yeah, it is what it says on the tin. We do have the RICS structure that's established. It's a measured approach. It's consistent, and the whole life carbon is a policy that's gaining traction. How that's going to change this year, yet to be seen. I mean, we've got this ministerial statement later by the end of the year. Change of administration, this could all change again. It's just an ongoing discourse. Sequestered carbon, so carbon that has been absorbed by trees before being turned into lumber and timber used in a building, has already been sequestered, so you can't deduct it from your proposed design. It only gets passed on to the subsequent projects that it benefits. The process is integrated with energy, water, and health and well-being as well, because dynamic thermal modeling, we're looking at overheating, thermal comfort, indoor air quality. So we're starting to see this sort of coalescence of much more holistic design. And collaboration is everything. It doesn't necessarily require a lot of work. I mean, it requires a lot more collaboration, a few more meetings up front to establish principles, general approaches, understand what might be required if the desired method is not allowable. So again, it's understanding, the carbon, you're thinking about whole life carbon as part of the design process. And we're designing for end of life, not end of material life. So, these materials with the correct assembly can be passed on to subsequent projects, and we can make them go a lot further than they already do, rather than just going for a straight demolition. Oops, I've got a second version of that. Oh yeah, that was the difference. It was the fact that the thinking by local planners, and a lot of this is, dare I say it, there's some social political influence coming in here, is to prioritize retrofit and reuse, or alternatively, if your retrofit and reuse is not viable, then you at least need to prove that your new build is going to be as sustainable as you can possibly make it. So it's not uncommon now for us to go through 4 iterations of, for example, of whole life carbon analysis to understand in micro detail the choice of materials, and collaborating with the architect and the structural engineers simultaneously to understand how we can benefit by fine tuning the design and reducing the carbon footprint. And I'm 5 minutes before time, so if there are any questions, then fire away. I appreciate there's a lot in there. So
It certainly was. Thank you very much, Richard. Yeah, most helpful. I've just asked if anyone's doing has had experience of conducting similar analysis and oh, 2 seconds. My screen's just changed sizes, which is slightly annoying. Where's my um, chat function gone? How weird's that?
anything I would say, like any webinar, if, today, later today, or tomorrow, or later in the week, you suddenly go, "Oh, I've got a question."
Yeah, yeah, yeah.
Do drop us a line, and we will answer it. So,
No, exactly. No, exactly. Yeah, and I'll post this so it'll be up as of tomorrow or Friday, as I mentioned. Yeah, Kingsley Hughes mentioned that he's already working with us. Not that I was trying to plug mesh necessarily on such a similar project. So if anyone else on the call has got anything to share, that would be good. We've only got a couple of minutes left. The other thing, I mean, obviously, when it comes to this sort of emerging policy and sort of how business as usual isn't necessarily the way forward. Can you see how that's when it comes to new build and a larger home build, is it a level playing field, or is this an emerging policy that's going to impact the sort of the smaller guys?
I mean, yeah, the problem with this sort of approach at the moment is it's quite a grey area. So sometimes you'll see, for the region we've done the most work with in the last 6 to 8 months, it's quite clear on the website that we should follow the RICS methodology, which we were. However, when it came to actual discussions, it was became quite apparent that the social political aspect of the administration was skewering the or
Mm-hmm.
changing the focus of the policy for a more social political outcome.
Mm-hmm.
So they're not strictly following the policy. So it's just one thing to be, when you start having those initial discussions with planning officers about this, is to understand very clearly how they feel about it and what the methodology is. And of course, with the ministerial statement saying, it's building regs at the end of the day,
Yeah.
it's still going to be um, a continuing conversation. I mean, I'm involved in the Future Homes Hub, and we've got some regular meetings going on there about how whole life carbon will be calculated as part of the future home standard. So I think it's here. Um, it's available. It's in BREEAM, it's a must if you want to get those excellent or outstanding credits.
Mm-hmm.
Um, but it will gradually, over the next 2 or 3 years, become mandatory in some form. What that is remains to be seen.
Yeah. Yeah. Yeah, Kingsley's just pretty much mirrored what you were just saying
Mm.
about the political situation. Amy's asked, wondering about organic materials. Are they behind the curve on EPDs? Often common sense doesn't prevail.
Um, so we know from EPDs on past projects that hemp is the wonder material. It's utterly fantastic. Its thermal performance isn't quite as good as rock wool, but depending on the product, the global warming potential is either zero or negative,
Mm-hmm.
mainly for its fast regrowth, and you get the thermal performance there. So you have to start thinking in terms of um, sort of thicker forms of construction. I mean, it's not so important in the roof, but certainly the external walls and the internal floor area. Um, Wood fiber, again, thermal performance wise, it's the same ballpark. Um, it's not the sort of the zero or negative GWP of hemp, but it's certainly very low. And then you get mineral, in terms of order, I suppose, then you get mineral wool, um, and then sheep's wool. Sheep's wool in new build is really to be avoided. There's a couple of reasons for that. It's great in historical buildings where they're very breathable and you need to still keep them breathing. The problem with the sheep's wool, there's a couple of factors. I mean, if you take raw wool, it just sags. I mean, if you put it in a cavity, it would just all sink to the bottom, and it wouldn't do anything for you at all. So it has to be woven together with like a polystyrene mesh. And so that starts to put up the embodied carbon of the material. The other factor, of course, is the methane in the production of wool, which makes it one of the least environmentally friendly in forms of insulation. I mean, but yeah, historical buildings, if you've got like a wattle and daub construction, for example, then it will give you your breathable fabric, and you can use it to improve the thermal performance at the same time.
I am going to try and get hold of some sort of biogenic building material guys, just because I quite like it when we have the product guys on, not because we want it to be an advertorial, but just because I think it's good from an education piece and just to get to learn more about what's coming up and what's coming up. And we haven't had a hemp guy on for a long time, so I'll look to do that.
Yeah.
In March, we've got Samita Singh and Duncan Baker Brown. They're going to be talking about the whole sort of move from virgin materials, or the need to move from virgin materials. So that should be a good session. And in a couple of weeks, we've got Beth Williams from Build Collective talking about non-cement foundations. So yeah, that's lots of these are all obviously this is the nature of meshwork and sustainability in the built environment. They're all linked, but we've got a whole bunch of topics coming up that are
yeah. Duncan's got a new book coming out. He's got
yeah,
the
yeah,
second edition of
yes,
his atlas coming out. So
yes,
looking forward
has
to seeing
indeed.
that.
Cool. Okay, doke. Well, thank you very much, Richard. We've gone past
Welcome.
1 o'clock now, so
Okay.
really appreciate that. Thanks everyone from the call, and yeah, that's been marvelous. And yeah, look forward to seeing many of you on the session next week. Cheers, then, guys.
Cheers, Simon. Bye.
Cheers.